So I'm going to begin at the beginning. With graphing lines. So this is a recap of everything we've done so far. And I'll start with graphing lines. So section 3.2, we're graphing lines. I'm going to skip that, independent, dependent. You can go back and look at that. Those are important. We're going to come back to that when we talk about functions later in the term. All right. So basically, when we have a coordinate plane, we split it into 4 parts. The 4 parts are called quadrants. It's really important. It goes counterclockwise. So quadrant 1 is in the top right. Then you have quadrant 2, quadrant 3, and quadrant 4. So notice the direction it goes in. Don't get that confused. Oftentimes students want to go 1, 2, 3, 4, because in their minds, that's what makes sense. That's the duh, 1, 2, 3, 4. But that's not how we do it in math. We picked a way to do it. And the way we picked to do it was 1, 2, 3, 4. So we're going in this direction, not the other one. So it's going counterclockwise, not clockwise. All right. So just kind of keep that in mind, because if you don't pay attention to that, what will happen is you'll go, oh, I think I know what it is, because that's how I would do it. Well, the way you would do it and the way we actually do it are different. So just kind of keep that in mind. All right. There's a point in the middle called the origin, which is not labeled, but there it is. It's the center. Right in the middle, it's called the origin. So, yeah. All right. Ordered pairs, you got an X, you got a Y. X, Y, X, Y, X, Y. It goes in alphabetical order. X is always first, Y is always second. I can't tell you how many times students, if they're not paying attention, get that backwards. So it's really important you go X and then Y. All right. Now, we've graphed 2 different ways. The first way that we graphed things was, what we basically do is we pick 3 X's, is we make a table. And the table would look something like that. You had an X and a Y. Again, you need to get used to making a table. Watching someone make a table and actually making a table are different. So you need to get used to actually making a table. So writing out the columns and the X's and the Y's and all the rigmarole that you don't really want to do necessarily. Get used to writing out the X and the Y's. So this is an XY table. We call it XY table. So in the XY table, we pick 3 X's. We can pick any X's we want. Doesn't matter what X's we pick an X. Pick easy numbers. Don't make them too big. If you don't like negative numbers, don't pick negative numbers. If you don't like decimals, don't pick decimals. If you don't like 0, don't use 0. If you don't like fractions, don't use fractions. If you don't want to use a number, don't use a number. Use the numbers that you like. 1, 2, 3. So pick numbers you like, use them. All right. So I like using 0, 1, and 2. That's my go-to number. If you give me a formula, I'm going to use 0, 1, and 2. You might like 1, 2, and 3. Use those numbers. All right, so we pick 3 X's, and then we plug it in, and we get 3 Y values. We're not solving anything or doing anything complicated. We're not moving stuff around. We just plug it in X, figuring out what Y is. That's it. All right. Now, those are ordered pairs. So these correspond to ordered pairs, 0, -1, 1, 2, and 2, 5. As you can see here. So X and Y. We create some ordered pairs. Then we graph the ordered pairs, like so. And practice that, you'll get it. Okay, great. And again, I'm going through it pretty quick. These are just things that you practice. They're just procedures. If you need someone to walk through you more slowly or need me to walk through you more slowly, I can do that. Again, I send an email out saying, let me know if you need some help or you want some help with this stuff. That's what I'm here for. I'm a teacher. I'm here to teach. I'm not here to fail you. That's not what I want to do. I want to teach you. I want you to learn the stuff. If you don't get the grades, then I fail you. If you get the grades, I pass you. But all I do is just go through on a piece of paper and go, yes, yes, no, no, yes, yes. That's my job. It's pretty straightforward. I don't actually do a whole lot extra. All right. Now we looked at fractions. So y equals 1/2 x plus 1. In this case, we said, okay, pick any x you want, but you want to pick x's that don't make things complicated. So we said, let's pick some numbers that will make it easy for us. So we picked numbers like 0, 2, and 4. Why? Because half of 2 is 1, and half of 4 is 2. If I pick something like 3, half of 3 is 1.5, which is ridiculous. It's a decimal. I don't want decimals. Or 3.5, or 3 halves, or 1.5. 1.5 is a fraction. I don't want fractions. I'm not here to do fractions or decimals today. So I gotta pick numbers that make it easier for me. So I picked some easy numbers, 0, 2, and 4. You won't always use 0, 2, and 4. It depends on what the fraction is, but you can figure that out. If the number comes out weird and wonky, pick a different number. Again, you can pick any x's you want. Pick the ones that will make it easier for you. Okay, so that's the big takeaway for 3-2. And you have that already. I can send all these out again, and I probably will right before the test. And so that was the first section we did. Then we went on. Let me silence this. Here. All right. Then we went on to section 3.3. So we've already graphed using a table. Now we're going to graph using intercepts. So let's think about how we're going to graph using intercepts. All right. So this was the procedure that we used for graphing a regular line, like y equals something. All right. But what do we do if the x and y are on the same side? Now all of a sudden we've got to figure out how to get y by itself by subtracting 3x from both sides, divided by -9, so on and so forth. Well, I don't want to do all that because that's extra work for me. I want to do the least amount of work to do a math problem that I can. So if I can do very little work, I'll try that. So what's the simplest way for me to do something like this? Well, the simplest way to do it is what's called an intercept. All right. Now, notice the way an x-intercept looks. It's got a number and 0, a number, then 0, a number, then 0. You probably, if you mess it up on the homework, you probably messed up and put 0 then a number. It's always a number, then 0 for the x-intercept. For the y-intercept, it's always 0 then a number. So just kind of making sure you don't get those backwards. Here's the procedure. To find the x-intercept, we set y equals 0 and solve for x. To find the y-intercept, we set x equals 0 and solve for y. So we went through a problem like this. I'm not going to go back through this again. There are YouTube videos of this. If you type if you type x-intercept, y-intercept into Google, it'll take you to a YouTube video. You'll be able to watch that YouTube video and start to figure it out. If that's not enough, just let me know and I can try to answer your question. All right, but again, it's just a procedure. So I'm just showing you this is the important part about this chapter. Making sure you know how to graph x and y intercepts. Those will be on the test. They absolutely 100% will be on the test. All right, and I went through all that stuff. You can read through all that later. I did several examples. All right. Do a new share. Okay. I don't know what happened, but we're gonna keep going. All right. Oh, I'm already shared it. Okay, so we're gonna keep going, and we move on to 3.4. So 3.4, we look at slope and rate of change. So we started looking at slope and the rate of change. I kind of described what slope was. Again, the main thing for you right now is making sure you know how to do it. Make sure you know how to do slope. If you're taking this class, if you're going to be taking more math, you will need to understand how slope works and what it is. That's why I did all that preamble at the beginning of the slides to kind of tell you what slope is so that you can know what it is. But right now, the main thing is that you know how to do slope. And so I'm going to just kind of walk through how we do slope. Again, this is all just preamble. It's important. I'm not saying it's not important. I'm just saying it's not really. You need to be focused on how to do it. All right. The steps are always the same. The steps are always the same. Basically, what you do is find the slope of a line. And I'll just skip to the end. Here we are. Basically, you label your 2 points, x1, y1, x2, y2. Like so. I label my 2 points. Every ordered pair has an x and a y. X is always first, y is always second. x1, y1, x2, y2. Write the formula out. You plug the values in, work the top and the bottom. So you see how we did that. All right, it's always subtraction. If you write your formula, you'll learn your formula. If you don't write your formula, you're not going to learn your formula. You're going to mess up your formula. So that's why you always write out the formula so that you can learn the formula, because that's how you're going to learn it, is by writing it out. If you try to skip steps too much, you're going to wind up messing yourself up. So we always label the points. We write the formula out. The formula is y2 minus y1, x2 minus x1. We do the top, we do the bottom, we divide. Okay. So I'm not going to belabor the point of that too much. That's practice. You're going to practice that and get it real good, and it'll be great. I know I'm going through that pretty fast, but that's just an old slide. Just make sure you know how to do that. Cool. So basically, recap. In section 3.2, we graphed things using a table. In section 3.3, we graphed lines using intercepts. In section 3.4, the first part, we basically said, how do you find slope? This is how you find slope. And we had a slope formula. We practiced that formula at home. And when we practice that formula at home, we get good at it. All right. This is the second part of section 3.4. More slope, because slope never goes away. It's always there just doing stuff. It's kind of like algebraic equations. It's just always there doing stuff. You're like, go away. No, it'll always, you're always doing that kind of stuff in chapter 2. All right. Now, slopes can be negative or positive. They can even be 0 or undefined. The way you know if a slope is negative or positive is you follow it from left to right. It's always from left to right. And so left to right, left to right. You always follow it, and then you see, is it going up or is it going down? If it's going up, it's positive. If it's going down, it's negative. That's it. That's how we figure out whether a slope is negative or positive. That's all we do. All right. So this is a positive slope. That's a negative slope. I mean, that's how you figure it out. Is it going up or going down? All right. And again, I just put another example of it. That's negative. That's positive. You just look at them. That's it. All right. Now let's look at something called slope-intercept form. And we're going to come back to slope-intercept form later. But right now we're going to look at slope-intercept form. Slope-intercept form has the form y equals mx plus b. So if someone says, what is slope-intercept form? You don't say y minus y1 equals m times x minus x1. You say y equals mx plus b. Slope-intercept form is y equals mx plus b. Now notice that they're in that equation, or in that I'm not calling it equation, but in that line, we call it, we have the letter m. Now we already said what m was. M is slope. The way we remember this is that mountains have slopes. People go and they ski on the slopes of a mountain. So m stands for slope. So if I look at this form, if it's in the form y equals mx plus b, it's super duper easy to figure out what the slope of that line is. Y equals 3x plus 4. How do I figure out the slope? Well, you subtract the 4, divide by the 3, multiply by the square root of rhinoceros, and add the tangent of an orange and a potato, and subtract the square root of science. No. The way you do it is you look at it. Y equals 3x plus 4. What's the slope? It's 3. That's it. It's 3. Y equals 4x minus 7. What's the slope? Well, you add the 7, subtract the 4, just divide by the square root of potato, and add the trigonometric asymptote of the square root of pencil. No, it's 4. The answer is 4. Y equals 4x minus 7, the slope is 4. They tell you what it is. If you have y equals negative 9x minus 1, what's the slope? It's negative 9. It's so easy, it's going to confuse you, because you're going to be like, that's too easy. This is math. We have to do stuff. No, you don't. They tell you. They just tell you what it is. Negative 9. All right. That's going to be useful to be able to look at a simple slope-intercept form and be able to say the slope is 4. The slope is 3. How you know? I looked at it. That's going to be useful. All right. We're going to use the word reciprocal in this section. All it means is flip. It's just a fancy math word that means flip. Reciprocal. Flip. Okay. In this section, the two kind of lines that we're concerned about are called parallel lines and perpendicular lines. So if you look like parallel lines are lines in the same plane that never intersect. They are always the same distance apart, which is sort of a really long form way of saying you have two lines that basically are going in the same direction at about the same tilt, about the same tilt, and they never ever meet. They never cross. So these lines right here are not parallel, because parallel lines are like train tracks. You never want train tracks to meet. They're like the lanes on a road, right? The left lane and the right lane on a highway. You never want them to meet. If you cross from the left lane to the right lane at the wrong time, that's a problem. So we want the left lane and the right lane to be two separate lanes. And they're parallel to each other. They're always the same distance apart. They never ever cross. So parallel lines are like this. They're like that. They're like this. Parallel. Perpendicular lines are different. They actually do meet, but they meet in a special way. They don't just meet in a kind of arbitrary way. The way that perpendicular lines meet is they meet at a right angle. Or a 90-degree angle is what the same what we say. Think about the walls in your house. If you look at the walls in your house in the corners of the rooms, I'm looking at the corners of my room, the place where I live. If I look at the corners of the room, they basically meet at what are essentially right angles. Now they're probably not perfect. They're probably offset a bit, but they meet at essentially at right angles. That's sort of what you're picturing when you're thinking about how these lines meet. They're like the walls of your house. This is one corner of your house. This is the other corner of your house. They meet like that. Or this is one corner of the house, the other corner of the house. They meet like this at a right angle. Okay. Parallel, perpendicular. All right. I will probably from now on, I will probably abbreviate it as perp rather than perpendicular. All right. So pictorially, what we can say about parallel lines is they never ever cross. That's what we can say about parallel lines in terms of pictorially, visually. Looking at them, well, that's what we can tell about them. What we can say about them mathematically is that they have the same slope. And that's the main thing that we care about mathematically, that parallel lines have the same slope. Perpendicular lines meet at a right angle. And what we can say about them is the slope is that they have opposite reciprocals. And we'll talk about what that means in a second. So let's look, for example, at these two lines. I've got y equals 2x plus 3 and y equals 2x minus 4. I look at those two lines and I go, those lines must be parallel. So I looked at them. Now, I still want to check, because sometimes my brain doesn't, sometimes I look at something and I get all discombobulated and I see it wrong. So I need to kind of like check and see. But there's a very easy way to figure out if they are actually parallel. And that's looking at the slopes. But look at the slope of the first line, it's 2, because I looked at it. If look at the second line, it's also 2. I just looked at it. The slopes are the same. What kind of lines have the same slope? Well, we just said parallel lines. Those two lines are parallel. All right. Perpendicular lines and their slopes. So I have y equals 3x plus 2. What's the slope of that line? 3. And I have y equals negative 1/3 x plus 10 over 3. Okay, so 3 is 3 divided by 1. I mean, hypothetically, I could write 3 is 3 divided by 1. If I flip 3 over 1, so 3 on top, 1's on the bottom, if I flip it, the 1 goes from being at the bottom, goes to the top, the 3 goes from the top to the bottom, and I get 1 over 3. If I take the opposite sign from positive 1 over 3, I get -1/3. So those two lines, I can tell without having to do a whole lot of work, those two lines are perpendicular, sorry. Now, let's try to figure out whether two lines are parallel, perpendicular, or the third option here, neither. So we're going to ask ourselves 3 questions, essentially, to try to figure that out. And the 3 questions we're going to ask are, number 1, are the slopes the same? Number 2, do the slopes have opposite signs? Number 3, can I flip one to get the other? So can I flip one to get the other one? If I can, then we're golden. All right. And then I went through and I kind of like wrote out my thought process. I'm going to talk through it. But you'll see. I just walked through it really slowly, just in case you want to go back and read it. But right now we'll just look at some, and it should be pretty obvious. All right. So you have 3 options. You have parallel, perpendicular, and neither. Those are 3 options we have for lines. So let's take a look at this line right here, and it won't be highlighted. But what you'll do is you'll kind of mentally highlight it, like you'll see and go, that's the important number. All right. So the first line, we have y equals 2x minus 1 and y equals 2x minus 4. Are the slopes the same? Yeah. What happens if the 2 slopes are the same? They're parallel. That's it. I didn't do any work. I didn't add anything, subtract anything, multiply anything, divide anything, take the square root of rhinoceros or potato. All I did was just look at the 2 lines, and I was able to kind of eyeball it and see that they're parallel to each other. All right, secondly, let's say I have 3/2 and -2/3. Well, let's look at the 2. Let's look at 2 of them. All right, are they the same? No. This is that, and that's this. They're different. Okay, so they're not parallel to each other. I can look at that and tell they're not parallel. They're not parallel to each other. Now, second question: are they perpendicular? Okay, let's see. Let's think about it. For any perpendicular, they have to be opposite signs and flipped. So let's think about: do they have opposite signs? Yeah. One's positive, one's negative. Are they flipped on each other? Can I flip 3/2 to get 2/3? If I flip 3/2, what do I get? Well, okay, 3/2 flips, give me 2/3. Yeah. So they're opposite signs and they're flipped. So opposite and flipped. Okay, I think I had this before. Means they're perpendicular. They are opposite reciprocals from each other. Okay, perpendicular. Now, let's look at this. I got 2x minus 1 and -2x minus 4. The question I want to ask is, are they parallel, perpendicular, or neither? So that's the question I want to figure out the answer to. So, are they parallel? Let's think about, for them to be parallel, they would have to be the same. Are they the same? No. One's a +2, the other one's a -2, so they're different. So because they're different, that tells me that they're not parallel. They're not parallel. okay? Because they're different. I mean, the numbers of they're both twos, but they're not, one's positive, one's negative. So they're not the same. Then the question that I have is, are they opposite signs? Well, yes. One's positive, one's negative. Okay, okay. Now, the third question I have, question number 3, is, are they flipped on each other? Can I flip a 2 to get a 2? No. If I flip 2, I get 1/2. So they're not flipped. So they're not parallel, they're not the same. In order for them to be perpendicular, they have to be opposite and flipped. They're opposite, but they're not flipped. Which means that one of the criteria that I need for them to be perpendicular doesn't work. So if they're not parallel and they're not perpendicular, then I guess they're nothing. So our answer would be neither. Because it doesn't work. Because they're not parallel, they're not perpendicular, therefore they're neither. All right, that's the basic thought process. You just ask 3 questions, and you answer those 3 questions. And once you answer the 3 questions, you think about what are the answers to those 3 questions mean. All right, to summarize this one real quick. A line with negative slope goes down, a positive slope goes up. If I have a line with a slope of 0, it goes straight across, which that happens sometimes. You'll see that, but I'm not going to really focus on that too much. All right, here's the main thing. Parallel lines have the same slope. So you see these are parallel lines, they have the same slope, 1/3. You see these are parallel lines, so they have a slope of 2. Perpendicular lines have opposite reciprocals, or opposite and flipped. So this is negative, that's positive, so they're opposite. If I flip 2/3, I get 3/2, so flipped. All right. And to figure out whether or not you have a parallel, perpendicular, or neither, you ask yourself 3 questions. Are the slopes the same? Yes or no? Question number 2, are they opposite signs? Yes or no? Question number 3, are they reciprocals? Can you flip one to get the other one? You answer those 3 questions, and then you think about what the answers to those questions mean. All right. I think we have time to start on the 3.5. And I went through that section pretty slowly. Again, if I go through a section slowly, it's because people have had trouble with it. You may be the first class that I've ever had that has 0 trouble with that. And that's really cool if that's true. But I definitely have had people who had trouble with it. Let me see. I'm not sure how far I'll go into this, but we'll start on it. I may not get very far on it, but I do want to go ahead and get started on it just so you can be able to look at it. All right, so now let me kind of recap what we've done so far. Section 3.2, we graph lines using a table. We picked some X's, got some Y's, did some stuff. Section 3.3, we graphed lines using intercepts. We basically plugged in 0 for some stuff and figured out some other stuff. So go back and look at that. That's section 3.3. We graph lines using intercepts. All right. Section 3.4. We looked at slope. How do you find the slope? What's the slope formula? We did, and we said this is a slope formula. Memorize it, practice it, write it down, learn it, do it. Section 3.4 continued. We looked at some special kinds of slopes. So we looked at negative slopes and positive slopes, and we looked at parallel slopes and perpendicular slopes, and we said some stuff about those. Again, go back, look at these notes, read these notes, learn these notes. Yes. All right. So we said some stuff about parallel and perpendicular. So far, everything we've been talking about at this point, we can split this chapter essentially into two parts. The first part of the chapter we can say is all about looking at a graph, and it's all about taking these ordered pairs, these points, and drawing stuff, essentially. We could say, basically, if I look at this thing, can I draw it? You know, y equals 3x minus 4. Can I draw that? That's all I'm trying to do is figure out in the first half of the section is how do I draw that? That's the whole first half of chapter 3. In between, there's this little thing called slope that's really important, but kind of like if you take 3.2 and 3.3 as the first half of the chapter, it's all about how do I draw stuff, right? How do I draw y equals 1/2 x minus 7? Okay, I have a way of doing that. So how do I draw something? And then we have this section in the middle where we talk about slope. This is the second half of that chapter, essentially. This is 3.5, which is all about writing equation lines. This is the second half. So I broke it into basically two halves. So this is essentially the second half of the chapter. Now, here's what we've done so far. We basically learned how to take a linear equation like y equals 3x minus 1 and turn it into a graph. In other words, we drew some stuff. We didn't have a picture. We went ahead and drew a picture. All right. What we're going to do now, I'm not sure how far we'll get into it. But what we're going to be doing in the future is we're going to take that graph on the left, and instead of us having to go from a picture, going from a table to a picture, we're going to go from going from like an equation, y equals 3x minus 1, which is this, and turning it into that. We're going to take that and turn it into this. So we're going to figure out how to turn that into this. And that's basically what the future looks like. Okay. I think I want to kind of stop it right there. And I'll say a few things and then we'll go. So I kind of want to keep there a little partition. I want to say this is what we did in the past. So make sure you work on those. This is kind of where we're going in the future. So let's look at those two, which I think my hand things are backwards. I don't know. This is the past, and that's the future. All right. I want to say a couple of things. Number one, on Wednesday, I'm going to I'm going to do a take-home assignment. Take-home assignment. So this is going to be on Wednesday. I'm going to do a take-home assignment, and it's going to be on this material right here. So kind of make sure you're ready for that, essentially. The take-home assignments that were supposed to be due today, the ones that you missed before, make sure you turn those in today by midnight. Text message, Canvas, send it in to me. I will send more. I will put the details for how to do that in the email that I'll send. I will start assigning some more homework. And I'm gonna say two things. You probably already basically have zoned out at this point, but I'll say it anyway because, you know, why not? Practice makes perfect. Make sure you're doing this stuff if you want to be good at it. If you don't care about being good at it, you don't have to practice it. If you don't care about passing your test or passing the class, I guess you don't have to do anything. If you do care about passing your class, if you do care about, you know, not having to take this class again, then you should work on it. If you don't care, I can't make you care. That's on you. You might have some other stuff going on that you think that's more important, some family stuff or life stuff or whatever. In that case, okay. I'm sorry you have all that stuff going on or bad stuff. And so I'm sorry. But if you do plan on actually trying to do well in the class because it's a big priority for you, you do need to practice this stuff. All right. Again, that's up to you. It's your life. You're making decisions for yourself. That's how it works, I think. You have to decide what's important and what's not. That's up to you. So make sure you do practice this stuff. If you do need help, again, there's an email that I sent that basically was about trying to ways that I could help, ways that Miss Anderson could help on campus. She's really nice. She's really smart. She will work with you. They're trying to keep everything relatively safe up there, and so she'll wear a mask and she will keep a certain distance if you need that and stuff. So she will help you out if you need help with that. I can do stuff over Zoom. If you need help with that, that's why I'm here to teach. Just let me know what a good time and day is for you, and we can figure it out and work around our schedules and figure out what we could do. That's about it.
I have a question.
Yes, what's your question?
So in my left plus it has like 3 assignments that are for today. Are they due today or are they due by Wednesday?
If they say they do today, they do today.
Well, I mean, it doesn't actually say the due date. It's just it's in the, what is that called?
The due date should be, if you click on the assignment, it should tell you the due date.
Okay, thank you.
Just click on the assignments and tell you the due date. If I don't know if do day or do Wednesday, I just assign them. All right. Well, that's all I have to say. Work on the stuff, do the stuff. If you care about the stuff, if you don't, that's fine too, I guess. You have stuff going on. You decide whether you're gonna do the stuff or not. And I think that's it. I'll send you an email. Other than that, have a good day. I'm gonna end in 5, 4, 3, 2, and 1. I'll see you guys when I see you. Goodbye. Have a great day.